For this first example, we're going to algebraically be evaluating a piecewise function. A piecewise function looks like this. You're going to have some function notation over here on the left side of the equal sign, usually f of x, but they could use g of x or some other form of y. And then on the right side, you're going to have a grouping of equations. Sometimes there'll be 3, like there are in this. Sometimes there's 2. It just kind of depends on the problem. How you want to interpret this is this. You have f of x is equal to, and you have 3 different equations. So what the f of x equals with the bracket really means is that f of x could be x squared plus 1 if x is less than or equal to negative 1, like that top line, or f of x is equal to x minus 3, but that only happens if negative 1 is less than x is less than 2, or in other words, x is between negative 1 and 2, or f of x is equal to the last function, which is 2 to the x power, and that happens if x is greater than or equal to 2. So this notation that we have here for this piecewise function is really shorthand for 3 separate equations. And then what we want to do is we want to evaluate those for the different values up here in the directions. We're going to evaluate for x is equal to a negative 1. When you do this, you don't put negative 1 into each equation. You only put negative 1 in for those that match the constraints that are over on the right side, which is just going to be one of those. So if x is equal to a negative 1, does that make this inequality true? Yeah, negative 1 fits here. So I'm going to plug negative 1 into this top equation. If you look at the other 2 equations, if you plug negative 1 in here, that's an untrue statement. This is all of the values between negative 1 and 2, but not including those end values. And we're plugging in negative 1. So that does not fit this inequality, so we're not going to plug it into this middle equation. Also, if you try negative 1 into this inequality, that's also a false statement. These are all the values that are 2 and larger, and we're trying to plug in something that is smaller than 2. So the only equation we're going to be plugging that into is this top equation. So we want to evaluate f of negative 1, and we're going to be plugging it into this top equation only, so that would be a negative 1 squared plus 1, or 0. So our final answer there is 0. In the directions, we also want to evaluate for when x is equal to 3. So we want to take a look at these inequalities, determine which one of these 3 that the number 3 fits into. We only use the top one if we're looking at x's that are negative 1 and smaller. We only use the middle one if we're looking at x's between negative 1 and 2. We only use the bottom one here if we're looking at values that are 2 or larger, and we're plugging in 3 this time. So we're going to use the bottom equation. So f of 3 is going to be equal to 2 to the 3rd power, and 2 to the 3rd power is equal to 8. So for these problems where you're evaluating a piecewise function, they're going to give you something that looks like this. You'll have f of x equals with a bracket and some equations here, along with some constraints after the word if. You'll only plug the values for which you're evaluating into one of the equations, and you'll base that on the constraints that are over on the right side. What I've written here in blue is just a way of kind of organizing your thought. This is more like what would be in your head. You normally would not write that down. You would normally just be writing down what we have here in red and using the original equation.